Hello, today we're doing section 5.1, which is the antiderivative. So this is kind of a lot of information I'm going to throw at you in one session. When I taught high school calculus, this was covered over a couple tests, so a couple units. So we're going to kind of go through it quickly. So just like everything in math, you learn addition and then you learn subtraction, you learn multiplication, and then you learn division. So you kind of learn how to do something and then you learn how to undo it. Well, we learned how to take the derivative in the first part of calculus. In the second part of calculus, we learned how to take what's called the antiderivative. So it's how to go backwards. So we're saying, say for example, we have big F being x cubed minus 2x squared minus 1. That is the antiderivative of this function, 3x squared minus 4x, because when I take the derivative of this, I get this, which is what I'm going to write, because the derivative of big F is 3x squared minus 4x. Note that f of x equals x cubed minus 2x squared plus 10 would also have that antiderivative. Also, if I had x cubed minus 2x squared minus 1,000, I would also get that same derivative, because what's the derivative of any constant? 0. So when you take the antiderivative, the general antiderivative, we always are going to write a constant plus c, because it accounts, you have an infinite number of answers, actually. So that's what this says here. We're always going to put that plus c, the integration constant. And in one of my classes, we named him Charlie. So for fun, we always said, don't forget Charlie. So don't forget Charlie. And one year we made a t-shirt with Charlie Brown on it. And it said, don't forget, and had a big picture of Charlie. So just remember, when you take the antiderivative, you always have that constant integration. So that's what this is talking about here. And then this is the symbol for integration. It looks like a kind of like an S almost. And that's because it is kind of like a summation, which we're going to talk about in our next section. So these are the basic integration rules, which you're going to want to memorize. The integral of 0 is c, because what's the derivative of any constant? 0. The integration of k is any constant. So say I had the integration of 2. Well, what do you take the derivative of and get 2? The answer is 2x. And again, you could always have plus c. So if you're integrating any constant number, you just add an x. The integration, this is saying that you can pull out a multiple. This is saying that the integral of the sum or difference is the sum or difference of the integrals. This is the rule that we're going to spend the most time on. It's the power rule for integrating. So remember, we had the power rule for taking the derivative. We brought the power down and we subtracted 1. Well, for the antiderivative, we're going to do the exact opposite. We're going to add 1 to this power and then divide by that new power. That's how we write this here. X to the n plus 1 over n plus 1. This is natural log of x, because the antiderivative of log is 1 over x. And we can't add 1. If you try to do the power rule here, you get 0 and you divide by 0, and that's, oh no, that doesn't work. E to the x is just e to the x, because the derivative of e to the x was e to the x. This one, you divide by the natural log of a, because we multiply by ln of a. Again, these look kind of scary. We're going to go over some examples that make it make sense. And then these guys, if you notice cosine, secant squared, secant tangent, sine, cosecant squared, these are special because they're the derivatives of the original 6 trig functions. What's the derivative of sine? Cosine. What's the derivative of tangent? Secant squared. So the antiderivative of secant squared is tangent. The derivative of secant was secant tangent. So that when we're going backwards, you're looking for secant tangent to change to secant. And kind of just a hint for you, whenever you write down something that starts with a C, this time when you write down the answer that starts with a C, you're going to change the sign. Because when we're taking the derivative, when you took the derivative of cosine, it was negative sign. So here we just put the negative with the answer. So anytime you write down something with a C, you're going to put a negative or switch the sign. So let's try to apply some of this. So what's the antiderivative of 4x cubed plus 2x? Technically, we're going to be splitting apart this integral, and we're finding the integral of 4x cubed plus the integral of 2x dx. but you never really see people do this step that much, but that's, you're allowed to do that because of the sum or difference rule. Then we're going to add 1 to this power and divide by it. So I'm going to add 1, actually, hold on just a second. I'm going to share a whiteboard with you for a second. Usually when I teach this integration rule, at first I like to just show a pattern because mathematicians recognize patterns. So I'm going to write down things, and I'm going to write down their antiderivatives, and I'm going to see if you can figure out what is going on. Okay, do you see the pattern? We're taking whatever power is here, we're increasing it by 1 and dividing by that new power. Taking whatever power is here, increasing it by 1 and dividing by that power. We'll notice the 3's canceled in this case, because when you increase that one by 1, this was 3, and then divide by 3, that divides to be 1. Also, you can check by going this way. You can take the derivative to check. So if I take the derivative of x cubed, I get 3x squared. Now, when you have a root or a fraction, just like when we first learned derivatives, you're going to rewrite it. When you add 1 to 1/2, you're adding 1, which is like adding 2 over 2. So that becomes 3/2. And then when you divide by 3/2, you're multiplying by the reciprocal. So that's the 2/3 in front. Be careful when you're adding 1 to negative exponents, because then that -5 plus 1 actually is -4. So that's kind of a really fast, trying to show you the pattern. This is the pattern rule, the power rule for antiderivatives. I also want to mention that I have a whole video on exponent rules. And again, check that out. If you don't remember exponent rules, x to the a times b, x to the ab, x to the a over x to the b, x to the a minus b. The b root of x to the a is x to the a over b. 1 over x to the a, x to the negative a. Again, I kind of go over this in detail in a video, and you guys should check it out if you're still confused about exponent rules, because you do need to know how to rewrite exponents in this unit. Okay, so let's go back to this example. So I'm going to add 1 to the power. So it becomes, so this is 4x cubed. So add 1 to that. That becomes 4, and then divide by the 4. So that just becomes x to the 4th. And 2x, you're going to add, this is understood 1. So add 1 to that. That becomes 2. You divide by that. So that becomes x squared. And then plus, don't forget Charlie. Then check, what's the derivative of x to the 4th? 4x cubed. So peel it down to check. The derivative of x squared is 2x. For trig, you just want me to replace the trig function. So cosine becomes sine, because the derivative of sine is cosine, and negative sine is going to be a positive cosine. When you write down the c, you change the sign. So the trig is actually easy. You just have to memorize which trig goes where. This one is rewritten for you. So again, when you add 1, the power rule is add 1. You can write it out if you need to. -2 plus 1 is actually -1. Then you divide by that -1. When you have a 5, that's just the k rule, k, so it's just kx. You can also imagine it's x to the 0 power there. There's no x, you're going to add an x. So if I simplify this, -3 over x plus 5x plus c. This one I need to rewrite it because it is a fraction. So bring that x squared up. When you bring the squared up, it becomes -2. So it actually is the same as this one. So it's going to have the same answer. Again, roots and fractions, you rewrite. So let's rewrite this. I'll rewrite it in red, and then we'll take the antiderivative in a different color. So this is 3x to the 1/2 plus x to the 1/3 minus 2x to the -1/2. Because that's the 1/2 power, and then when you bring it up, it becomes negative. A word about the dx, that just lets you know the constant of integration is x. So when you take the antiderivative, the dx goes away. So we're going to take the antiderivative by adding 1. Adding 1 for fractions is tricky for people. Just remember you're adding common denominator. So I have 1/2. So add 1, that'd be 2/2. So if you had a half plus 2/2, you have 3/2. And you multiply by 2/3. So this 3 cancels until you end up getting 2 as your coefficient there. Plus add 1, so adding 3/3 here becomes x to the 4/3, and then you put a 3/4 in front. Add 2/2 here, so that becomes x to the 1/2. You multiply by the reciprocal, so multiply that 2 by 2, and you get 4. Plus c, don't forget Charlie. So that's that one. This one, kind of my tip for helping remember, is if you have a single term on the bottom, you separate, and then you simplify. So all the s's, single, separate, simplify. So we're going to pull this apart, and they all are going to be over x to the 5th, because it's like you had a common denominator before you combined these guys. Now we're going to simplify. So we separate, we're going to simplify by subtracting. So that becomes x squared minus 1/3 minus 5. 5 is like 15/3. So that becomes negative 14/3 plus 3x. I'm going to write that as 3/x. 3x to the negative 1. 3x to the negative 1, that's tricky because that one you cannot add. That one is going to be natural log. So x to the 4th, that simplifies to over x. So now we're going to do the power rule for the first two. Add 1, so it becomes x cubed, and then you divide by the new power. Add 1, so adding 1 is like adding 3/3, so that becomes negative 14 plus 3 would be, why can't I think 11? Negative 11/3. And then you would multiply by negative 3/11, so that becomes positive. And then when you have something over x, that just becomes the natural log of x. So this right here is like 3 times 1/x, and you can pull that 3 out. Antiderivative of 1/x is the natural log of x. So that's that one. This one we're going to multiply it out. You don't know how to do the chain rule, reverse chain rule yet, and also that one really wouldn't work with this problem. So we're going to simplify it first, because you want things like this. You want it to be just a stream of a polynomial before you take the antiderivative. So let's square this out. It would be the first term squared, whoops, not 8. 4 squared is 16. So 16 y to the 4th, plus multiply these together, that would be 12y squared, oops, then double it. Multiply and double, so 24 y squared plus 9. So the antiderivative of this, you add 1, so 16y to the 5th over 5 plus 24y cubed over 3 plus 9. When it's a constant, you just add the x. So this is 16/5 y to the 4th plus 8y cubed plus 9x plus c. This one I'm going to distribute, so secant x, tangent x minus secant squared x, and then hopefully you recognize both of these guys. This is the derivative of secant, so its antiderivative is secant. And this is the derivative of tangent, so its antiderivative is tangent. So those are the answers here. And again, I know I'm throwing a lot of you at you very quickly. I actually have many reviews on my YouTube channel going over various integration problems. So there's a lot of resources out there for you to learn how to do this. Now the antiderivative of e to the x is just e to the x. The antiderivative of that's a to the x. So we're going to write it as a to the x, but then divide by the natural log of 3. And then this is like the example I did earlier, that's like 3 times 1/x. So 3 ln of x plus c. So this is just recognizing integration rules. Integral of e to the x is e to the x. Integral of the number to x, so like not x to a number, but a number to x, You write that same thing and then you divide by the natural log of the base. So that's that one. Now we're going to very quickly talk about the concept of a differential equation. It's an equation involving a derivative of a function. So we're going to solve it using an initial value. So that helps us find what C is. So if I want to find what the original function is, I take the antiderivative. The antiderivative of f prime would give me f. The antiderivative of 3x squared, add 1 and divide by it, so that'd be x cubed. And sine would be negative cosine. Plus, don't forget Charlie. Now we're going to use this point, this value they gave us. We're going to plug in 0 here and set it equal to 3. So 0 cubed minus 2 times cosine of 0 plus c equals 3. So this is 0, cosine of 0 is 1. So negative 2 plus c equals 3, so add the 2 over. So c equals 5. So that means your function is this guy, but instead of writing c, you're going to write 5. So that's your original function. Take the derivative of it, you get this, and when you plug in 0, you get 3. Now this time we're going to have to do that process twice because they gave us the second derivative. So first, antiderivative of this would be f prime of x equals, this is like 2x to the negative 2. So add 1, that would be 2x to the negative 1 divided by negative 1 plus c. So this is negative 2 over x plus c. I use this first one, f prime of 1 is 4. So when I plug in 1, I'm supposed to get 4. So negative 2 plus c equals 4, so c equals 6. Okay, so let me change my color so we can see what I'm doing. So f prime of x is equal to negative 2 over x plus 6. Then I need to integrate this again, and then I'll get f of x. F of x equals, when you have that over x, that's natural log. 6 is going to become 6x plus another c. Sometimes people call this c1, and then this one c2. Now I'm going to use this one. When I plug in 1, I get 3. So negative 2 natural log of 1 plus 6 times 1 plus c needs to equal 3. Natural log of 1 is 0. So 6 plus c equals 3. So subtract 6. So this c2 equals negative 3. So that means your function for this one, f of x would equal negative 2 natural log of x plus 6x, and then minus 3. You're plugging in that negative 3 for this c down here. So that gives you your original function, and you could check it. Take the derivative of this, you would get this, negative 2x plus 6. Take the derivative of this, you get that. And when you plug in these values, they should check out. Okay, so that is all we have for this unit. Again, let me know, or for this section, let me know if you have questions, and good luck on your assignment.